Morning, students. I am Dr. D.P. Anuja, Associate Professor of Mathematics, Arumigi Palniyandavar Arts College for Women, Chinnakalayamuthu, Palani. Today, we are going to see transportation problem using northwest corner method. Okay, we can solve this problem using northwest corner method. In our last video, we have seen using northwest corner method, find an initial basic feasible solution. Here we are going to find the optimum solution of the transportation problem. See here, the sources are O1, O2, O3. The destinations are D1, D2, D3, D4. The supply is 250, 350 and 400. The demands are 200, 300, 350 and 150. Here, the total demand and total supply are equal. So, the given transportation problem is balanced transportation problem. Okay, first we have to find the initial basic feasible solution. Okay, we are choosing the northwest corner cell. Here, the northwest corner cell is X11. We have to find the initial basic feasible solution for the cell X11. X11 is equal to minimum of 200, 250. The minimum value is 200. It is in the demand column. So, we cross the first column. Subtract 200 from 250. The remaining value is 50 is here. Next step, we have to choose the northwest corner cell. Our northwest corner cell is here. The least cost element is 1 is here. We have to find the initial basic feasible solution for the cell X12. X12 is equal to minimum of 50, 300. The minimum value is 50. Subtract 50 from 300. The remaining value is 250 is here. The minimum value is in the row. So we cross the first row. Next, our northwest corner places here the cell X22. We have to find the initial basic for this cell. Minimum of 250, 300. The minimum element is 250. Subtract 250 from 350. The remaining value is 100. Minimum value is in the column. So we cross the second column. Next step, the northwest corner places X23. We have to find the initial basic feasible solution for this cell. X23 is equal to minimum of S2, B3, 100, 350. Minimum element is 100. Subtract 100 from 350. Remaining value is 250. 100 is in the S2 row. So we cross the S2 row. Next, northwest corner places X33. Minimum value is 250, 400. Minimum value is placed in the third column. So we cross the third column. Last, only one column is available. X34. Value is 150. The following is the initial basic feasible solution table. Next, we find the total transportation cost Cij into Xij. 3 into 200 plus 50 into 1 plus 250 into 6 plus 100 into 5 plus 250 into 3 plus 150 into 2. The total minimum transportation cost is 3,700. Now, we optimize the transportation cost. First, we have to check the total number of allocated cells. is equal to m plus n minus 1. Here we get m plus m minus 1 is equal to 3 plus 4 minus 1 is equal to 6. Hence, the basic feasible solution is non-degenerate. Now, we find the optimal basic feasible solution for the basic cells. The UV equations are U1 plus V1 is equal to 3, U1 plus V2 is equal to 1, U2 plus V2 is equal to 6, U2 plus V3 is equal to 5, U3 plus V3 is equal to 3, U3 plus V4 is equal to 2. Put U1 is equal to 0, we get U2 is equal to 5, U3 is equal to 3, V1 is equal to 3, V2 is equal to 1, V3 is equal to 0, and V4 is equal to minus 1. Now, the UV values are substituted here. U1 0, U2 5, U3 3, V1 3, V2 1, V3 0, V4 minus 1. For the non-basic cells, the net evaluations are calculated by Zij minus Cij is equal to Ui plus Vj minus Cij formula. Here Z13 minus C13 is equal to U1 plus V3 minus C13. Substitute the value of U1 V3 and C13. We get minus 7. Next, Z14 minus C14. Substitute the value of U1 V4 and C14. We get minus 5. Next, Z21 minus C21. We get 6, which is greater than 0. Next, Z24 minus C24, we get minus 5. Next, Z31 minus C31, we get minus 2. Next, Z32 minus C32, we get 1, which is greater than 0. Here, Zij minus Cij is not less than or equal to 0. So, we cannot get the optimality condition. Here, 2 positive value. So, we choose the most positive here. The most positive cell is 2, 1. To draw a loop that starts and ends at the cell 2, 1, such that all corner cells of the loop are basic cells. Okay, we start here 2, 1. To draw the loop like this, assign alternate plus minus sign to all the cells with right angle turn in the loop. Plus minus, plus minus. Consider the cell with a negative sign. Compare the allocated value 200 and 250 and choose the minimum value. Now subtract 200 from the cells with the minus sign and add 200 to the cells with a plus sign. We get the new table. Now we have to check the total number of allocated cells is equal to m plus n minus 1. Here the condition is satisfied. Hence the basic feasible solution is non-degenerate. For the basic cells, the UV equations are U1 plus V2 is equal to 1, U2 plus V1 is equal to 2, U2 plus V2 is equal to 6, U2 plus V3 is equal to 5, U3 plus V3 is equal to 3, U3 plus V4 is equal to 2. Taking U1 is equal to 0, we get U2 is equal to 5, U3 is equal to 3, V1 is equal to minus 3, V2 is equal to 1, V3 is equal to 0, and V4 is equal to minus 1. The values are here. For the non-basic cells, the net evaluations are calculated here. Z11 minus C11 is equal to minus 6. Z13 minus C13 is equal to minus 7. Z14 minus C14 is equal to minus 5. Z24 minus C24 is equal to minus 5. Z31 minus C31 is equal to minus 11. Z32 minus C32 is equal to 1, which is greater than 0. Here all Zj minus Cij is not less than or equal to 0. Hence the optimality is not reached. Now we draw the loop starting from the new basic cell. Three comma 2. Select the minimum value from allocated values to the cell with a minus sign. Subtract this value from the cell with the minus sign and add to the cell with a plus sign. We get the new basic cells. Okay, now we have to check the non-degenerate condition. Here m plus n minus 1 is equal to 6. The condition is satisfied. Next we find the UV equations. Using UV equations, we have to find the values for U and V. As here, U1 is equal to 0, U2 is equal to 4, U3 is equal to 2, V1 is equal to minus 2, V2 is equal to 1, V3 is equal to 1, V4 is equal to 0. For the non-basic cells, the net evaluations are Z11 minus C11 is equal to minus 5, Z13 minus C13 is equal to minus 6, Z14 minus C14 is equal to minus 4, Z22 minus C22 is equal to minus 1, Z24 minus C24 is equal to minus 5, Z31 minus C31 is equal to minus 8. Here all Zij minus Cij is less than or equal to 0. Hence, the optimality is reached. The current basic feasible solution is an optimum solution. The optimum basic feasible solution is here. The total transportation cost is 2,450. Okay, we will continue another example in our next class. Thank you.